Continuing lesson 5-6, solving two-step inequalities. We look at the try it on example 2. The jazz band needs to raise at least $600 to travel to an upcoming competition. The members of the band have already raised $350. If they sell calendars for $8 each, how many calendars would they need to sell to exceed their goal? Okay, so we can think about on this problem, how much do they have so far? $350 that they've got so far, okay? And then they're going to sell some calendars. How much are they selling the calendars for?
$8 each.
$8, okay. Do we know how many calendars they're selling?
No.
Okay, what are we going to put there then?
X or something.
Okay, we can put a variable. We could do C for calendars if you want. So $8 times however many calendars. And this will be how much they'll have altogether. $350 plus the money they make from these other calendars they're going to sell. And they want this to exceed their goal. What's their goal? $600, okay? So for them to exceed their goal means the amount that they're bringing in here has to be what? Greater than. Okay, in this case, exceeding the goal would just be greater than. All right? Initially, what they said, they kind of changed gears on us. They said they're going to raise at least $600. Then later, they said they're going to exceed their goal. Okay? So at least 600 would be greater than or equal to. Since their last statement they said was they want to exceed their goal, we're going to say it's just greater than 600. So our first step on the inequality is trying to get our variable term by itself. In other words, we're trying to get this 8c by itself. They are adding a 350 over here, or you can think of that's a positive 350. We get rid of something on that step by doing the opposite. So we would need to subtract 350 in order to get rid of that. 350 minus 350 is 0. So those cancel out. And then if we subtract those, 600 minus 350
250
is 250. Good. Okay, then as the name suggests, two-step inequalities. We've done one step. We have one more step to go here. So at this point, they are multiplying by 8, means we're going to divide by 8. When we multiply or divide, we need to think about whether we need to switch our inequality sign or not. At this point, would we need to switch our inequality direction? No? Why not? Good. We did not multiply or divide by a negative number. We divided by 8, which is a positive number, so that symbol stays the same as it was. And then when you divide that, 250 divided by 8.
31.25.
Okay. Would somebody like a fourth of a calendar?
Oh, no.
Okay, so we're going to round it off, so we're going to say they would need to do at least 32 calendars. A way to check your answer here, we could multiply if you did 32 times 8, and you can make sure, either make sure combined with the $350 that would be more than $600, or if we did our first step correctly, just making sure that 32 times 8 was more than $250. Example 3, they want us to solve the inequality here. The difference is we got some subtraction stuff, we got some negative stuff happening. So what you might want to do a problem like this is in the middle here when they're subtracting, you can go ahead and add the opposite. Remember, make your two sign changes there. And then this one we got to be careful about. Basically, at the beginning, that's actually like a negative 10. So we're trying to get the negative 9/2 x by itself. we need to get rid of the negative 10. So what's going to cancel with the negative 10? A positive 10. Good. Another way you could think about that is you could say, well, they're subtracting 10, I'm going to add 10. That's fine. Or you could say, well, they're adding a negative 10, I'm going to subtract a negative 10. Subtracting a negative 10, I'll just mention to the side here, if you subtract a negative 10 and if you add the opposite there, that's going to be the same as adding 10. Okay? So, however you want to look at that. But we do need basically a 10 to get rid of that negative 10 there. Okay, so when we do that, we've got negative 9 halves x is less than 90. And we got one more step. So we could say that they are multiplying by negative 9 halves. We can divide by negative 9 halves. On this problem, you might want to, some people might look at that and say, well, I'm going to change that to a decimal. The problem with doing that is sometimes, depending, like if our fraction, if we had 7/3, for example, that would give us a repeating decimal. That's not going to work out very nice. So this is in general our better option. Say they're multiplying by that, we're going to divide by that. If you did this on your calculator, by the way, if you were typing that in, you would do 90 divided by, and then you could put in parentheses negative 9 divided by 2 to make sure that you're getting the correct answer. One thing we need to consider here is that we are dividing. Anytime we multiply or divide, think about your inequality symbol. Is our inequality symbol going to stay the same, or is it going to change here? It's going to change. Why?
Negative.
Because we divide by negative. Good. Okay? When you divide that out, you should get negative 20. And again, that one's in your book there. You can see what it was, but hopefully that helps you to see. The book did it a little bit different. If you want to do it their way, that's fine. Just the idea, if you multiply by a reciprocal, you get 1x, which is the same as x. And that's okay also. And just remember, if we were doing this by hand for the dividing part, it's keep, change, reciprocal. Change that into a multiplication problem, and you could get the same answer. Okay, again, watch. Since we did divide by negative, make sure you switch your inequality sign there. Okay, so if we look at the try it then, they want us to solve this inequality. First thing on this problem, since they are subtracting, you may want to go ahead and add the opposite. Adding the opposite, remember it's our two sign changes here. Instead of minus 1/2 x plus negative 1/2 x. I've just seen some people, if they didn't do that, their next step they got 1/2 x instead of negative 1/2 x. They forgot the sign. Adding the opposite just helps us to make sure we keep that as a negative 1/2 x. So this problem at the beginning, we see the 5 there. To get rid of a 5, we would need to subtract 5. Okay, 5 minus 5 is going to cancel out. We need to do the same thing on the other side to keep this balanced. So this one on the left side, they're multiplying by negative 1/2, we could say. So we could divide by negative 1/2. And again, dividing by a negative is going to switch our sign around. It's going to change from greater than to less than. So then our answer would be x is less than negative 50. And these problems, there are multiple solutions. Basically, we could put any number less than negative 50 into the original problem and we would get something that would work. For example, we could put a negative 100 in place of x. Obviously, that's less than negative 50, so that should work. If you look at the key concept, just to make sure we understand this, with two-step equations, there's only one solution, only one answer, like x equals 5. Two-step inequalities that has multiple solutions. Like if we got x is greater than 5. Any number that was bigger than 5 would work. Okay? So like 5.5 would work, 7 would work, 1,000,000 would work. We look at the do you know how number 4. Joe ran 4 miles yesterday, wants to run at least 12 miles this week. Write an inequality that can be used to determine the additional number of days Joe must run this week if each run is 3 miles. Then solve the inequality. So a problem like this, you know, a lot of you guys I'm sure can look at this. You could figure this out. Some of you could maybe even figure out in your head what's going on here and get an answer. It did ask us, however, to write and solve an inequality. So we have to have an inequality written down and we have to solve that inequality. Having said that, though, there are different ways that we could write our inequality and still be correct. So what we can do is think about how much has he already run? 3 miles, okay. And then he's going to run some more. How much is he going to run each day? Okay. How many days is he going to run? We don't know. So a variable, maybe D for days if you want. Okay. And he wants to run at least 12 miles. So that would be greater than or equal to 12. Okay. So this is the amount he's running altogether. Has to be at least 12, so greater than or equal to 12 miles. There's another way we could look at this we'll talk about in just a minute. So our next step here for solving this, we're trying to get our variable term by itself. They're adding 3, so we can subtract 3 on both sides. Keeps our inequality balanced the same way it was to begin with. 12 minus 3 is 9. Then the last step, they're multiplying by 3, so we can divide by 3. Should we switch our sign around or not? No, we just divided by a positive number, so we're okay. 9 divided by 3 is 3, so that means that it would take at least 3 days at that rate of 3 miles per day for them to run at least 12 miles. Another option that you have for working this out, some of you, if you thought that you would prefer just working it out and not having to write an inequality, you might think about the steps you would do. If you do 12 minus 3, that would tell you how many miles they have left to run, which would be 9 miles left. And then you could divide that by 3. We're splitting that up into 3s. And this our days that we're running has to be greater than or equal to that. To me, the first way we did this is easier to come up with. For some people, though, that second option might make more sense to you. So either one of those, as long as you've written something with an inequality sign, then you've written an inequality and you're technically okay. Number 5. Another 2-step inequality. We're trying to get the variable part by itself, so the 6.5x. We've got a 4 out in front here on the left side we need to get rid of. Remember, if you were doing this by hand, if you subtract 4, they're adding 4, we subtract 4. Make sure you keep your decimal points lined up. Treat that as 4, not 4/10. And so you subtract that would be 32 and 5/10. Then our second step, they're multiplying by 6 and 5/10. We would need to divide by 6 and 5/10. When we do that, should we switch our sign around? No, we just divided by a positive number again, so inequality stays the same. When you divide that out, you get 5.
I got 5.5.
Number 6, Thomas has $1,000 to spend on vacation. His plane ticket costs $348.25. If he stays 5.5 days, at his destination, how much can he spend each day? Write an inequality and then solve. So we have to write an inequality in order to work this one out again. So one option to start out with on this problem, writing our inequality, $348.25 that they spent on the plane ticket, plus we could say 5.5x or some whatever variable you want, however much he's spending per day here. If you want to do D for in a day, you could do S for spending, just maybe a cursive S so it doesn't look like a 5. This amount he's spending, then he's got to stay in his budget here. So the amount he's spending has to be less than or equal to $1,000. So once we got the inequality set up, we're trying to get our variable term by itself. So if we subtract 348.25 on both sides here, be $651.75. That's basically what they have left to spend after the plane ticket. So our second step, they're multiplying. So we would divide by 5 5/10. Should we switch our sign around? Nope, keep it because we didn't multiply or divide by negative. And when you work that out, that's 118.50. Which means on average the most they could spend would be $118.50. Obviously the half day they would only be able to spend half of that amount. Number 7, trying to solve this inequality. They're subtracting here, so if you'd like to add the opposite, you need to see that as a negative 3/5 x. We need to get rid of the 12 in front. That's a positive 12, so to get rid of that we would need to subtract 12 on both sides. Good. And when we do that, 39 minus 12 is 27. And then we could say negative 3/5 is right next to the x, means they are multiplying. We need to divide. So we'll divide by negative 3/5. Should we switch our sign around? This time yes, because we're dividing by negative. So it changes to less than, and when you divide that out, negative 45. So x is less than negative 45 would be our answer.